Okay. Good morning, all. Welcome to the Geology lab sessions. I'm Dr. Chandrasekhar Pagasnali, Assistant Professor, Department of Civil Engineering, BMSIT Institute of Technology and Management, Bangalore. Today, I'm going to explain and solve about the borehole problems especially in the dam construction area, tunnel construction areas. Why we are drilling the boreholes? What do you mean by borehole? Borehole is nothing but it's a narrow, deep penetrated, big diameter of the hole. Okay. Generally, we used to drill this borehole for exploration of minerals, oil and gas, and also for geotechnical point of view. So for mineral exploration, generally we used to drill the borehole for minimum 300 to maximum 800 meter, more than 800 meter boreholes. And then for oil and gas, we may go for kilometers, maybe a 3 kilometer, 4 kilometer down below the earth to understand the subsurface geology, geological structures, different rock types, and behavior of the rocks, dip and strike of the rocks. And also for geotechnical point of view, whether it's a hard rock, soft rock, or it may be unconformities, geological structures, especially these boreholes will give us the very good idea of the subsurface strata. Especially we use these boreholes in dam construction and even reservoir construction, tunnel, and even for superposed highways, erecting the pillars, metro work. We used to drill these boreholes to understand the different rock types and geological structures, to understand the geological structure, faults, folds, and joints. Now let's start with the borehole problems. So generally, it's a dam site area. Core was struck by 3 boreholes, A, B, C. These are the 3 boreholes at a triangular grid pattern, and AB is equal to south 55 degree west, and that's equal to 600 meter, and AC is equal to south 30 degree east, that's equal to 800 meter at a depth of 35 meter, 155 meter, and 180 meter respectively. That means there are 3 boreholes. These A, B, C are 3 boreholes. They are in a triangular grid pattern, and from each borehole, so this A borehole is 35 meter, and B borehole is 155, and C borehole is 180 meters. Okay, and from A borehole to B borehole, the distance, horizontal distance will be 600 meter, and A borehole to C borehole distance is 800 meter horizontal distance. And in the geographical way, and where it is deploying, south 55 degree west, okay, and AB, and AC is south 30 degree east. Now let's come to the what you need to determine from this given data. You need to determine the attitude of limestone formation, especially the dip and strike direction of this particular boreholes. And second question is, find out the depth at which the above confirmatory borehole, depth of 700 meter, depth at 700 meter distance, and south 40 degree west. If it is there, what is the depth of this borehole D? Now let's come to the scale point. We need to convert the scale. 1 centimeter is called 100 meters, because we have here the 300, 150 meter, 180 meters. That's too long, very difficult to draw it. That's why we are going to convert this 1 centimeter is equal to 100 meters. And given data is AB is equal to south 55 degree west, that's equal to 600 meter. AC is equal to south 30 degree east, that's equal to 800 meters. A borehole is 35 meter, B borehole is 155, and C borehole is 180 meters. Let's start with before going to the next part of this step, we need to calculate the gradient of the borehole. So A borehole depth is 35 meter, B borehole depth is 155 meters. The common depth of these 2 boreholes are 35 meters, and remaining is 120 meters. And between these 2 boreholes, the horizontal distance is 600 meters. So this thing is AB gradient is equal to 120 by 600. That's equal to 1 by 5. That means 1:5. This is a gradient of AB. And like that, the AC boreholes, the gradient will be this is common depth of A and C borehole is 35 meter, remaining C borehole depth is 145, and AC gradient 145 by 800, that's equal to 1:5.5. This is the gradient we need to calculate. The next part is we need to draw the sketch based on your given data. So here we have given the data that's about AB is equal to. First we need to draw this north, south, east, west directions in the plus mark, and we need to draw this, and we need to take the protractor and scale, mark this AB is equal to south 55 degree west. Fix the mark here, and AB south 55 degree west. This approximate it will come here. Okay, and what is the distance? It's a 600 meters, and as we are taking the scale is 1 centimeter is equal to 100 meters, so you need to mark this 6 centimeters here. That's called a AB. Like that, AC is south 30 degree west, south 30 degree east. That's about 600 meter. Measure it 600 meter by the scale and mark it here. And you got A borehole, B borehole, and C borehole, and these three are in a triangular shape. A borehole depth is 35, B borehole depth is 155, C borehole depth is 180 meters. Right. So now we got this A, B, and AC. Now let's start with the gradient. What is the gradient of AB? Is a 1:5. And what is the gradient of AC is equal to 1:5.5. So AB is 1:5 means you measure from A to the 5 centimeter here. So you can mark this place, and 5.5 you can mark it here. You'll get this. Connect these two. Again, this is called our strike line, and you need to transfer this strike line into the center. You need to transfer by using your set square. So this we will get, that's called a strike direction of the boreholes. This is a strike direction, and take a protractor and measure with this. This is fix it here and measure with it. This will become north 75 degree west, and as well as it becomes south 75 degree east. Now we got the strike direction. Okay, now we need to determine the true dip directions. So dip and the strike and dips are perpendicular to each other. Keep the protractor here and mark the 95 degree angle and draw a line. You will get the true dip directions, and you can measure with the protractor. That will become, you will get 15 degree. That's called your strike direction. You got altitude of this strike direction, north 75 degree west and south 75 degree east, and you got the dip direction also here. So we need to calculate the another fourth borehole, that's called a borehole D depth. The confirmatory borehole, we drilled it here. This is a confirmatory borehole. We got 700 meter length, horizontal distance, and south 40 degree west. South 40 degree west here, measure it and mark it, and mark with the 700 meters here. So here we got another point that's called a E point, that is called our gradient of AE. Okay, that will be 4.3 centimeter from here to here. Okay, how to calculate this borehole depth D? So you need to, there is a formula for that. Gradient of the borehole depth D is equal to gradient along AE. What is the gradient here? 4.3, and horizontal distance of AD, that's called 700 meter, plus borehole depth at A. This is 35 meters. So all you need to fix it here, and you will get the 197.79 meters. This is all about the borehole problems. It is one type of method that's called the triangular method. Now let's start with the square method. This is second type of methods in boreholes. So here we are giving the 4 boreholes. See here the 4 boreholes. 4 boreholes are proposed at ABCD square grid, and a coal seam is encountered at a depth of 300 feet, 800 feet, and 600 feet. We are giving only the 3 boreholes depth. Okay, and and the sides of the square of the grid will be at 3000 feet. Okay, so borehole A is deployed in the west of C and south of B. Okay, all we need to calculate is the attitude of the coal seam. That means you need to find out the dip and strike of the borehole, the coal seam. So determine the depth at D borehole, which is north of C. Okay, this is the question, and you need to calculate the attitude of the coal seam, dip and strike of the coal seam. Okay, now as usual, we need to calculate the gradient of this AB and AC, but here the scale will be the 1 centimeter is equal to 300 feet because the sides of the grid will they have given 3000 feet. So 1 centimeter is equal to 300 feet means the sides of the grid will be the 10 centimeter by 10 centimeters. So that's easy to calculate it. So now let's go to the part of that. So here you need to draw this north-south and east-west, and here we need to draw this the called gradient first. Okay, and AB borehole, the gradient will be 1:6. Measure this 1:6 here and mark it, and AC is 1:10. Here we got it 1:10. That you mark it here and connect these 2 points. Okay, and this is called our strike line, and we need to transfer this strike line into the center point. That's called strike directions. Okay, and perpendicular to this you need to draw the true dip direction. The dip and strike are perpendicular to each other. So we got strike direction is 59 degree southeast, and here the true dip direction north 31 degree east, north 31 degree east. Now, so next question what we have is determine the depth of borehole D, which is in the north of C. So this is borehole C, A, B, C, D. These are 4 boreholes at 4 corners. Okay. Now we need to determine the borehole depth of D. Okay. Join this AD borehole and measure the distance of horizontal distance, and you got this the gradient of AD boreholes. So here AE. So how to calculate the depth that is equal to gradient of along AE. This is a gradient of along AE multiply with the horizontal distance of the horizontal distance plus depth at borehole A. Okay, so here the horizontal, this gradient along AE is 5.2 multiply with the 4230, that's along this, and 300, this is the depth. All along you will get it 1113.46 meter of the complementary boreholes depth. This is all about our the borehole problems, especially encountered in the dam construction, tunnel construction, and even for metro construction, erection of pillars. So boreholes are very important the what you call tool to identify and getting the information of the subsurface. And this is all about the borehole problems. Thank you very much for participating in this session. Thank you one and all.